Hi, sixth graders. All right, we're going to continue to build on our knowledge of equivalent ratio or of ratios by looking at what makes a ratio equivalent. So yesterday we learned, or in our last lesson we learned, how do you find or write ratios? Important things that we saw was that whatever word comes first is the number that should come first. Whatever word came second is the number that should come second. We also learned that Miss Englander is not very good at drawing, but that's okay. All right, so we all have different strengths. All right, how do we find equivalent ratios? So first let's talk about the word equivalent. So the word equivalent, we know from fractions, means equal to, right? So if something is equivalent, it is equal to. So if it's a ratio, if it's an equivalent ratio, it's a ratio that is the same as another ratio or has the same relationship. So it means that two ratios it's comparing two ratios and saying that they're equal to each other. So two ratios that describe the same relationship. So two ratios that are equal and describe the same relationship. So we know that ratios compare things. Nope, no S. Okay, we know that ratios compare two things, right? And they're comparing the relationship between those two things. So when it's equivalent, it is the same type of relationship. So it's an equal relationship. All right, so equivalent ratios are equal. Ratios that are equal, they are the same. Okay, so we're looking for same things. All right, let's go and check out what this means. So let's say that I have an example, and in my example, I have 1 to 3. Okay, so there's one ratio right there, 1 to 3. In my next ratio, I have 2 to 6. My job is to find out if these ratios are equivalent. So I have ratio A and ratio B. Are these two describing the same relationship? Well, the way that we can find out is by using multiplication or division. So I can ask myself, how do I get from 1 to 2? Well, to get from 1 to 2, I had to multiply by 2. How do I get from 3 to 6? Well, in order to get from 3 to 6, I had to either multiply by 2 or 6 divided by 3 gives me 2. So because we multiplied by the same thing on both sides, this ratio is, or these two ratios are equivalent. So these are equivalent. Okay, we can also set this up so we look at the value of the ratio. So the value of the ratio is when you just turn it into a fraction. Okay, and we know how to do fractions. Okay, so if we look at the values, turn to a fraction, that gives it a number. Okay, so if we turn it to a fraction, that gives the ratio value. So if we say 1 to 3 is equal to 1 over 3, that's the value of that ratio. if I compare it to 2 to 6, and I make that into a fraction of 2 to 6, I can now set these two fractions side by side and make a fraction, an equivalent fraction. So let's take, let me get rid of this. Let's take our 1/3. We're going to write 1/3 first, and we're going to want to multiply to get to 2 over 6. So what do we multiply to get from 1 to 2? Well, I multiply by 2. That gives me this 2 right here. To get from 3 to 6, I also multiply by 2. So 2 over 2 is equivalent. So there's another way that we can solve it. So let's go ahead and look at example B. Okay, example B says 4 to 3 and 20 to 15. So here's our two ratios. Again, you can solve this two different ways. So first, we can multiply or divide. I can ask, how do I get from 4 to 20? Okay, well, 4 to 20, I multiply 4 times 5 equals 20. How do I get from 3 to 15? I say 3 times 5 equals 15. So these two ratios are equivalent because I'm multiplying by the same number on both sides. I could also take and turn these into fractions. I could say 4 over 3 is equal to 20 over 15. What do I multiply to get from 4 to 20? Well, I multiply by 5. 3 times what gives me 15? Well, again, I'm multiplying by 5. So because I have 5 over 5, it's equivalent. It's the same fraction. Okay, so these are the same ratios. So we're building on what we learned way back when we were talking about equivalent fractions. Now we're taking them and setting them to ratios. So these are equivalent. All right, let's look at one more example. We're going to look at one more example. Example C. Example C says 5 to 7 and 10 to 21. Are these equivalent ratios? Well, let's look and see what we had to multiply by to get from one to the other. So to get from 5 to 10, I multiplied by 2. To get from 7 to 21, I multiplied by 3. Nope, that's a 3. 7 times 3 gives me 21. So these are not equivalent because when I set these to a fraction, I have to multiply 5 times 2, but I have to multiply times 7. This is not an equivalent fraction to multiply by. So this does not work. So we would say not equivalent. These ratios do not explain the same relationship. These are not equivalent. All right, it is your turn to do a try it. So I'm going to give you 2 try-its to do, and I would like for you to please check for equivalence. All right, so let's do 1 to 2 and 3 to 4. Are these equivalent? And then the second try it I would like for you to do today is 8 to 3 and 8 to 3 and 16, there we go, to 6. Are these equivalent? All right, Cougars, go ahead and hit pause right now so you don't hear me solving this. Otherwise, come back in just a second and be ready. All right, so from 1 to 3, I'm going to multiply by 3. From 2 to 4, I multiply by 4. So because those are not the same number that I'm multiplying by, this one is not equal or not equivalent. They do not describe the same relationship. Okay, to get from 8 to 16, I multiply by 2 because 8 times 2 equals 16. To get from 3 to 6, I'm multiplying by 2. So these ones are equivalent, right? They're both equal because I multiplied by 2 on both sides. Okay, 6th graders, it is your turn right now to tell me how did you do in this lesson? What is your level of understanding? So go ahead and put your answer out into the box and then answer your essential question. How do we find equivalent ratios? Answer that somewhere on your paper. And then if there is anything inside your notes that doesn't make sense, please make sure that you're marking that so that you can come back to the Google Meet and ask me for help or ask tomorrow when we come to class. Okay, head on over to Big Ideas, do your practice work, and as always, thank you so much for your hard work, and make it a great day the Cougar way.